normal Eclipse feed that I was trying to use. We are using an iPhone. We won't be able to capture everything, but we'll try to do our best. So we're here in Exmouth. You can see that the light is starting to get low. There's a total solar eclipse that's about to happen in approximately 15 minutes or so, just a little bit less. And we are prepping for that. I apologize that we weren't able to get the other live stream webcam working. We are doing our best here out in the field. We are running an experiment called Citizen CATE. It is a community science experiment where we will have members all along the community in 2024 using the telescopes and cameras that you see behind me to observe the eclipse in 2024 that crosses over the United States. We're here in Australia as a test to determine how well the cameras work, what the procedures are, and to figure out what the best plans are for our 2024 eclipse. So here in Australia, we have 10 members. You can see them behind me. Here we have members from Indiana University. Over here is a team from Rice University. And here is a team from the University of Maine. They are all helping us recruit members for this Citizen CATE campaign in 2024. Let me turn the camera around and you'll be able to see the setup's a little bit better. Every one of our members here has a computer. That computer is observing the camera from the total solar eclipse. You can see here, we are almost at totality. That is a live picture of the sun right now, where the moon is almost covering the sun. We shortly will be experiencing totality, and because I'm on the iPhone instead of with our other camera, unfortunately I will not be able to show you the solar eclipse directly, but I will leave the video feed on one of these computers so that you can all experience what we're seeing with the computers with us. So you can see here, this is the application we're using for the total solar eclipse. And I apologize for the jerkiness of this video. You can see here that we are just about, let's see, we're just about 10 minutes away from totality. So here we have our team from Indiana University. That's Rachel Weir and John Carini from Indiana University. Here we have Pat Rife and Charlie Gardner from Rice University. And over here we have Nikita Saini and Sean Lach from the University of Maine. And of course we have our lovely folks here at the hotel who are helping us prep everything for the eclipse.
10 minutes to C2, so we got to start paying attention.
All right, C2 is second contact. Second contact is when the moon fully covers the sun, and that becomes the total solar eclipse. You're going to notice very shortly that the light here is going to start getting dimmer and dimmer. It's already starting to feel cooler here. The temperature is dropping. And we have here our team that is getting ready for totality. These are the telescopes that we're using for these experiments. These are refractor telescopes. They're actually fairly small. The cameras on the back, you can see right there. That camera actually measures polarized light, not just regular light, but the polarization of light. So if you wear sunglasses, those polarized sunglasses cut down certain angles of polarized light. These telescopes measure all of the angles of polarized light, and that allows us to study the solar corona in a special way. More details about all of this, of course, will be posted on our project website and published in journals, so stay tuned for that in the future. I apologize that I can't take live questions. Obviously, we are trying to prep for everything. Let me see if I can get an Eclipse viewer. I wonder if I can take a picture of the sun. Stand by.
Yeah, I just took one. Going over the door.
Let's see. Where is the camera? Here's the camera. No, I don't think that's gonna work. There it goes. All right. It's unfortunately very fuzzy. I apologize. That's not working very well. But we are very close to totality, about 8 minutes. William over there is calling out the timing. Once the eclipse starts, there will be about 58 seconds of totality here in Exmouth, Western Australia, where we will be able to see the solar corona. And again, I apologize, I can't show it to you with our webcam, but I'll put the live feed on the screen so that you'll see everything that we're gonna see. The screen's gonna look a little bit weird because our cameras are set up to take high dynamic range exposures. So what they're gonna be doing is taking about a sequence of 8 frames every 1.5 seconds. Those 8 frames start off with short exposures, then move to longer and longer exposures until they cycle back to short exposures and back. And we put those together to create a high dynamic range image where you'll be able to see the brightest and the dimmest features in the solar corona. That post-processing will happen after the eclipse is done, but you'll be able to see the screen cycling through those different exposures as we move forward. And I apologize, I can't take questions, but of course, hopefully I'm answering them and anticipating everything. So for those of you who are unfamiliar, a total solar eclipse happens when the moon crosses in front of the sun in the sky. And the moon happens to be exactly the right size so that it can cover the sun most of the time when this kind of alignment happens. And this alignment doesn't happen every month. It happens about, on average, once every 18 months. And when that happens, the moon blocks the very, very bright disk of the sun, which is what gives us our light every day, and allows us to see the solar corona. That's the outermost atmosphere of the sun, which normally we can't see with our naked eye. You have to use specialized equipment to see it. And that corona is full of magnetic fields. It has plasma that is millions of degrees. And we in the science community are still study it to better understand our star, the sun. And of course, by analogy, understanding other stars. You'll notice, of course, everybody is using special eclipse viewing glasses. Those are solar viewers that block out the very bright disk of the sun, because outside of a solar eclipse, the sun is so bright, you look at it with your naked eye, it will cause damage. During totality, it is safe to observe the sun with your naked eye, only during totality. We have 5 minutes to go. You'll notice that the light is getting very, very dim right now. It's not clouds, it's the moon. In fact, it just got very noticeably dimmer in the last few seconds.
It's going quickly. It's getting darker, like obviously.
Yeah, I know.
I want to look, but like.
Right now, looking at the sun through the solar viewers, there's only a sliver of sun right now. Here's a live feed from the cameras. That bright sliver at the top right is all that's sun right now, and why it's very dark out here. Of course, you don't notice how dark it is with your eyeballs because your pupils are getting larger and larger just like they would at night. But the colors flatten out. Everything gets a little gray.
11:26. Oh my god.
Come on, you made it good. Record saving.
All right, just about 3 minutes coming up. Are you ready with your shade?
3 minutes.
Yep. They're gonna use that.
That's fine. That's fine.
My dust cap. You want to just
Sean, are you ready with the shade for after totality?
Shade there. Got our cap here.
Excellent. So you'll notice that the telescopes currently have filters in front. That's because the sun is not yet fully eclipsed, and we have to protect the cameras. So they have these special solar filters right here. Those solar filters cut out the bright light of the sun by a factor of about 100,000 so that the camera can remain undamaged. But during totality, we have to remove those filters. And that's what everybody will be doing during totality. I'll show you that as totality starts, and you'll be able to see the reactions of the people. Then I'll move over to the computers so that you can see what we're seeing on the screen during totality. Immediately before the end of totality, we have to shade the telescopes again so that when the sun reappears from behind the moon, we'll be able to protect the telescope. 2 minutes to go, 2 minutes. And it's getting dimmer and dimmer and dimmer by the second. Right now, the amount of sunlight reaching us here is about 5% or less of what it normally is, and that's getting dimmer and dimmer by the second.
Okay, that works.
We have 90 seconds to go. Oh, you probably can't see it in the iPhone, but we can actually see Venus.
Give us a 10-second count.
Let's see if we can see it with the iPhone.
I think I'm gonna leave the track shooting through here.
I think we may not be able to see it with the iPhone. Ah, that's a bird. You probably can't see it.
5, 4, 3, 2, 1. So that's 1 minute to go.
All right, we have 1 minute to go. Everybody has now started logging the data on their computers. And I think you might be able to see it, but it's getting dimmer and dimmer here. It is almost twilight at this point. It is almost twilight. We have a very, very slim crescent of the moon left.
30 seconds.
30 seconds to go. I have to take off my sunglasses. It's so dark.
So weird.
The amount of light right now is what you'd see at about twilight with the sun under the horizon now.
10, 9, 8.
7, 6, 5, 4, 3, 2, 1. Totality! Oh my God. Let me see if I can capture this with the iPhone. Probably not. This is probably not going to work, everybody. This is, of course, on the iPhone, nothing like what it is in real life. Nothing at all.
30 seconds.
Let me show you what we're seeing on the screen.
I'm shaking.
20.
Oh, hey. Look at the Sarah.
Oh, I'm sorry.
Sarah has it.
10.
Oh wow, here comes the Bailey.
5, 4, 3. Oh, there it is.
Cover up.
All right.
Oh my god.
Sorry, the Osmo is going crazy right now.
Vlog.
Dan, how do we fix the Osmo? It's going crazy.
Oh, did it get?
It got a little crazy.
Yeah,
Stand by, everybody.
Might need to turn it off and turn it back on.
How do I turn it off?
Just press and hold.
Okay. Sorry, everybody. 1 second, please.
Okay.
That's why I said repeatedly that everybody should have their own binoculars. That is just a non-starter.
All right. Well, the Osmo is not working, unfortunately. So the camera stabilizer is not working right now. I apologize for that. There we go. All right, got it fixed. Totality is over. It was just a short 1 minute of totality. I apologize that we couldn't capture everything for you. It is impossible to say exactly what it felt like. Sarah, what was it like?
Oh, I'm like almost crying. It was so freaking cool. Like, wow. Holy shit. I literally started crying. I really did. That's crazy. Oh my god. It was so bright. I did not expect it to be that bright. Wow.
And
Yeah,
it
that
was
was-
very
that
symmetric
was so
because it's
cool.
solar max.
Everybody hypes it up, and then you
Solar
finally
mass
look
looks
up and
like
see the corona. And you're like,
Very
oh
symmetric.
my god, it's very cool.
I did. I like as soon as it started, I started crying. I was like, oh my god. Wow.
Charlie,
Yes.
how was it?
That was great. Never seen totality before, so it was pretty awesome. It got very dark, which is weird in the middle of the day. You can still see Venus.
Yeah? Yeah? All right, let's ask our hotel staff. How was it?
Yes, very amazing.
You can understand why people thought the world was ending, right?
Lucky you were here to explain it to us.
Nikita, what do you think?
Oh my god, that was amazing. Like really out of this world kind of view. Oh my god.
Hole in the sky.
That's right.
Hole in the sky.
A hole in the sky.
Really nicely calibrated data is not gonna measure to what we actually saw.
It never can.
And
It never can.
Your eye does much more justice than any camera ever
I have
can.
goosebumps.
Cameras, yeah. Cameras don't do it justice. You have to see it.
All right.
Amir, I got stuck. I was just transfixed and I forgot to start my timer. So I was off by a couple seconds on the 10 seconds remaining, 5 seconds remaining.
This is what happens to scientists. Even scientists get transfixed by the thing we're studying, which is why we study it. So everybody, we are now going to be doing our post-eclipse calibrations. You can see that the solar filter is back on one of the telescopes. We have lens caps still on some of the other telescopes. We have to do some additional calibrations, taking data called flat fields. That means that we have to put basically a white piece of glass in front of the telescope so that instead of seeing a focused image, you just see bright white everywhere. What that does is it allows us to see the variations from pixel to pixel that are inherent in the camera. And that allows us to correct everything and flatten the image so that you don't have any artifacts that are from the camera itself. When you have the lens cap on, we're also taking what are called dark frames, where you're not actually looking at the sun or at any light source, but you're measuring the amount of noise that's coming off the camera just by the camera operating itself, and we are able to then subtract that out. So both the darks and the flat frames allow us to get an image that is as close to reality as you can get, where you're essentially removing the effect of the camera from the images. After that, we have to back up all of our data. We have to ship all of this equipment back home, and in case something gets lost, we're backing up our data onto USB drives separately from the computer. We're going to upload it to the cloud, and then we will get to process that data once we get back to Boulder. Let me turn the camera around. Thank you all for joining us. I'm going to be ending the live stream in just a minute. If you have additional questions, you can find us on Twitter. You can find us on Facebook. I am Amir Caspi, AmirCaspi. If you want to send me an email or send me a message on Twitter, you can Google me. Unfortunately, let's see. Here you go. Take a screenshot. That way, if you need to contact us and talk about Citizen CATE, please feel free. We are going to be opening up recruitment for the Citizen CATE project along the Eclipse path sometime later this summer. So if you are interested in participating, please look out for that, and then you'll be able to join us. Of course, all of the data that we took today is going to be made public. It's going to be available for your use and enjoyment along with this live stream video. So thank you all for joining. I wish I could have shared even more of the miracle of the eclipse with you, but for many of you, you'll be able to experience this in 2024 in the United States on April 8th next year, where the eclipse crosses from Mexico into Texas, over the Midwest, up into Maine and Canada. And I hope that if you do not live along the eclipse path, that you'll be able to travel or see another live stream next year. Thank you all for joining. It's been lovely.